So for our dark beam additional effect, I want to create this static effect that you see behind objects here based off your focus distance, but I also want it to not apply the static anywhere where there's red. So you can see here's a good example. In the very center where it's actually so dim you can't see anything, it's returning this static value, but where it's red, there's no static. In order to do this in Shader Graph, what we need to do is we need to compare the R and the G channels. Since this is a grayscale image, we can just check if the difference between them is greater than a threshold. So we take in the URP sample buffer, we get R and G. You could do R in any channel realistically. I just did G because it's the next channel. And I check that it's greater than the threshold. If it is, this goes to a branch and it just immediately returns the color. So if it's red, it just returns the red. If it's not, what it does is it takes in our UV and it adds time.delta time to it. And then it puts this as a random range as the seed. This goes between 0 and 0.05. And then again, we have our distance fade here. This is the same as the other one. And we multiply that by our random range. And then we add this to our material. You can see here there's now a static effect being applied to it. So if the red value isn't greater than the G value, it returns this static effect, and that's how you have this kind of cutout. This one's really simple, but if now I go to a different effect and I change it to, say, X-ray, and I make sure to change both properties here. So now you can see for X-ray, this has this pulse that goes out. That's this one here. So this one's a bit more complicated. It takes time, multiplies it by the scan speed, and it feeds it into a sawtooth wave. A sawtooth wave is a wave that just goes from, say, 0 to 1, and then resets back to 0. So unlike a sine wave, it doesn't go, 0, 1, 0, -1, 0. It doesn't have that periodicity to it. It instead just continuously climbs and then resets to its lowest value and then climbs. So this one actually goes from -1 to 1, and I set this between 0 and 30. So this is a way of checking the distance. This value here is the maximum distance of our scan. Then I take in the position of the camera, the position in world space, I subtract them, get the length. This is the exact same as getting the distance. Honestly, I think I did this at probably 1 a.m., so I have no idea why I did it this way instead of just getting the distance. But we take that value, and then what we do is we subtract this sawtooth wave from it. We also take in our scan size, we negate it, we feed it into a vector 2 for the x and y, and this vector 2 is just -1, 1. Now, the subtracted part, we're going to feed that into two comparison nodes. One that checks that it's greater than the scan size, greater than the negative scan size, and one that checks that it's less than the positive scan size. So this is how we create kind of a ring. We feed those two comparisons into an and that gets put into a branch over here that returns, if it's true, it returns this pulse value, otherwise it returns 0. We feed this into a remap node. This remaps it from our actual eye depth into a -1, 1. Now what we do is we take the absolute of it, and then we take a 1 minus. So this will make it so it fades around the edges. And the 1 minus just makes it so instead of the edges being bright and the center being dark, it's the center being bright and the edges being dark. Then we multiply it by strength. Finally, from our branch here, we multiply this value by our URP sample buffer and we add it back to it. So it makes it brighter. And then that goes to our X-ray. And that creates this pulsing effect that you see here. You can see it really well in the arm cannon, but it applies to every object that you can see. For something like this, it will only work for objects that write to the depth buffer, because we are checking the positions in world space. It gets that from the depth buffer. There are ways around it. I just really did not feel like coding that much. So you can see certain objects where they are considered transparent all the time, like this platform here that you can see through. This color isn't actually being applied to it. That's just because of how the distance rendering works. So it's not perfect, but it works. So now if I change this instead to be our thermal effect, just change the renderer. This one here, what I did was I reduced down the motion blur. A lot of people had said that it was a little bit too much, or a lot too much. So I seriously reduced it down. And I added just a little bit of heat distortion on the edges. This one is not too bad. So we take in time, we feed it into a vector 2, and we multiply this by our heat distortion speed. Then we negate it, and we multiply it by 2 different values. This just makes it so it offsets 2 different noise textures. Then that is into a tiling on offset node, and those each go into a gradient noise. Then we also have a heat noise scale parameter. This we feed into the top one just directly. This one we divide by a certain amount, and we feed that in, and that creates 2 different scaling noise maps, and they offset by slightly different amounts of time. We multiply them by each other, so now we have something like this. And then what we're going to do is we're going to also take the screen position, split it, get the absolute of the X value. We're going to remap the green value from being -1, 1 to 1, 0. This, since it's center, it goes between -1 and 1. We multiply those by each other so we get this kind of just the bottom corners. Then we feed that into a power node. So this is very similar to what we were doing before when I showed you the screen distortion for the echo. This is the same thing, but it's only going to be the bottom corners. So then that gets multiplied by our gradient values, so they only appear in the corner. And then we take the screen position, which is the UV. We multiply it by this here, so we get these. We negate it. We multiply it by a amount. And then we add it back to the original UV. It's really hard to see on here. If I turn this up to say 10 here, you can see there's now this really strong distortion. Having it this strong, wherever it appears black, it's actually also going to show black on the screen because of how the blitz source, it doesn't wrap. So you need to make sure that it's a fairly low value. And then we sample the URP buffer at that UV. This is the same way you create most distortion effects, is by modifying a UV and resampling the color buffer. And that gets fed out. For the combat, it just directly takes the sample buffer here and feeds it out. This is a bit of a waste. You don't need this here. Ideally, when you're not needing it, you would just turn this off and make it so this shader isn't active at all. But I just have it set for testing purposes and playing around. So now if I go back in here and I actually press play, I'll do a bit of a demonstration of all the effects and their final look. So combat, we can set our beam, use different beams here. If I switch to our thermal visor, you can see, and for the arm cannon, I added a bunch of different special effect. So it's a custom shader. It's not using the universal shader. It's mostly copied from it, but I've added a bunch of different stuff to it to give it a little bit of extra effects. So now we can do all this different stuff here. And the thermal visor responds appropriately. If I go into our X-ray visor, same thing here. We have that pulse effect. Over to the dark visor. Now we've got similar thing. But you can see as I look at something closer, that noise actually gets closer or further away. So that's by me modifying the focus distance in the script. And then finally, if we go to our echo visor, I've got these here. So I know it's not appearing sometimes when I shoot. That's just because the collision detection isn't great. This mesh is really complicated, so baking a collider for it was a pain. But yeah, this is the final effect. And I hope that this has been useful. There's a lot of applications in different rendering modes of how you could use a feature like this. I was doing this just for fun because I enjoyed the series, and now that Metroid Prime 4 is out, I've scratched that itch, so I'm going to switch to something different soon. I'm going to start working on a full HLSL tutorial uncovering everything from fragment shaders, vertex shaders, geometry shaders, keywords, blend modes, alternative passes, light modes, parallax occlusion, everything that way, and show you how to write a Uber shader from the ground up. So that'll be coming in the future. But thank you for watching. That's all there is for this.